ladies and germs. I hope you have a seatbelt installed in the chair that you're sitting at. Yeah, this is going to be a hefty problem. Not because it's hard, but there's only one example in the textbook, and your boy went through the time of finding it. And I'm going to explain to you real briefly how it works, and then we're just going to rush through the problem. So, anyway, here it is. If you guys don't watch this, you'll most likely miss it. And even if you got it wrong on WebAssign, still watch this so you know how to do it. Alright, so we're going to be doing this question: where does line through this point and this point intersect that plane? You don't just simply get the vector between these two like that and then just plug it in and get some numbers. The reason is we have to have a scalar for this vector. So because if you think about it, the point between here, the line through here and here is only such a distance. So let's say you have 2 points. These are the points given, and the plane's over here, it's like this, but they want to know when it intersects, but it doesn't if you just get the vector between these 2 points, right? So that's why we have to apply the scalar. So there is no scalar here, but where do we see that t scalar come in? It's in the parametric equation. So yeah, you're gonna have to get the parametric equation for those 2 points, and then from there you do plug it into this equation here. So yeah, let's do that real quick. So we still need this vector that we found for these 2 points, right? Because to find the parametric equation or unique line, we need those 2 points to find the vector. Once we have the vector, we can choose either one of those points to make our parametric equation. For this, I chose that one because it looked easier, right? Because this one has more numbers and this one has less numbers. I was like, oh, okay, it would be easier to do it with that one, so that's what I did. So we set up the step before we do the final parametric equation. So that's what this is, and here's in blue, 4t, 3t, and 2t, and then I circled those in blue so you can know where I got that from, and then underline these. This had a 0, so I wouldn't, and then here's this one, that's where that's coming from. And then from here, this is the parametric equation. This guy, that's the parametric equation. I just wrote it in a linear way, same thing, doesn't matter. So now you can see I underlined these in different colors to show, you plug these in to their corresponding points, right? Because we have the t now, and we have that unit vector to see it can stretch out to where we actually need to find the intersection. So, okay, so we did it. So, if you think about it, this is the same as just plugging it in here. So I just went down the line to get this, and just set it equal to 8, and then we got t equals 2, and then we plug t equals 2 into x, and then y, and then z, and we got 9, -6, and 5. So these were actually the numbers for mine on WebAssign, so I'm gonna submit it live, and it was right. So that's good. Yeah, so anyway, I hope this helps.